Okay, so today we're going to actually tell you what a valve job is, what it does, and how it is done. There's a couple different ways to do it. The number one way I like to do it, I'm old school, so I use stones, right? A lot of guys use CNC machining, which is good. I mean, there's nothing wrong with any way. I mean, you have metal cutters and you have a CNC cutter, and then you can do it with the stones. Stones is the way I was taught. I'm kind of old school, so I like doing it that way. I can control everything and see what it does, and I can just do the personal touch with it. So anyway, just to give you an idea how this works, because I'm sure a lot of people just say, "I do a valve job," and they don't really understand or know. So first thing you have to do is determine what needs to be done. So usually we bead blast the head, clean it up real good, then we mark the seat so that we know what's going on with it, and I'll show you what I'm talking about right here. See this XR650R head? So a lot of times we'll take a Sharpie or some blue Dykem. It depends. You know, if you're fancy, you're going to use blue Dykem. I prefer a fat Sharpie. They're cheap and they actually work really well. So you just basically color this whole seat in, right? We're going to see what we got. So once you get this kind of colored in, and by the way, Al Baker is the one that taught me how to do this many years ago, back in the early 80s when I was working for him as a young guy. So what I'm going to show you right now is that there's different angles we put on the seat. The first angle that's the most important, obviously, is going to be this angle here. The valve is typically cut at a 46-degree angle, right? Not a 45. You don't want a perfect 45. A 46, because the valve's going to wear a little bit, it's going to seat. So you always want that valve to face into the 45 cut in the seat. So we want to see how wide the seat is, number one, and we want to see where the seat is going to sit on this valve, okay? So the first thing I do is just give it a little love tap. So we just kind of smack it a little bit. And a lot of times you can see there'll be a slight trace on the valve face where it's hitting, okay? So you want this to sit in the middle of the seat, right? In the middle of the face of the valve, in the middle of the seat. So we can raise those seats up and down by changing the 30 or the 60, depending on how we want to bring up or lower that 45 to sit on the valve face better. And if you look real close, you probably can't see it. It's barely visible. But there's a black trace and it's pretty close to center on this one. So we're pretty good on that. So why do we do different angles? Why don't we just do the grind going straight in, right? Well, it's all about air flow and dynamics. So the more air flows the path of least resistance. So the more that you can get resistance out of the way, the better cylinder fill you're going to get. So if we cut that seat at 145, it's got a sharp corner turnaround, right? So the path of least resistance is just going to drop straight in. It's not going to roll around the corner nice and easy, and it's going to slow down as it does. So that 45 needs to have some enhancements, so that 30, 45, then 60. And you can do 5-angle grinds, which I don't really think is necessary on a single cylinder motor. Multiple cylinder engines, more angles are going to make a difference, and you're going to match those cylinders, and you're going to get better performance because one cylinder is not going to drag the next one down. The closer you can get those and match those cylinders, the more power you're going to make and the crisper that engine is going to run. But for these single cylinder motors, man, it's all about just getting that thing to seal and getting a reasonable amount of flow angle and not restrict the intake at all, right? So anyway, that's just a quick understanding of what a valve job does as far as getting it cut, what the angles are for. It's just to get that nice smooth radius of airflow, and air is very much like water when it comes to that path of least resistance, right? So if you'll notice also in these ports, you'll see the transition here, right? This XR650R, believe it or not, is extremely good porting. I've actually messed up a couple heads trying to make it better. There's not a lot of casting flaws. There's some slight little things here. There's a couple little pieces down here. I'm gonna turn the light on so you can see. See if I can get the light to go on. There you go. So you'll see this little casting flaw right here. That's gonna be one of the things that you would take out when you're porting. But the thing is, when you're trying to port a cylinder head and you just want to get rid of this transition step, right? You want to make this as clean as possible. You don't want any step dropping in this way and resisting any airflow going into the valve face. But when you try to get rid of this, a lot of times you actually have to use a ball or a flame on your porting tool, and you actually take out material here and here. So it's really tough not to remove material. And on a cylinder head like this, it's actually, in my opinion, it's way too big. The ports are actually too big. This motor was designed to actually be built to put like a larger piston or a larger CCs, and it likes that, so you can throw as much as you want at it. Bigger cam, higher compression, and it just keeps building and building and building. So I've actually ruined a couple of these things by porting them and actually slowed down the airflow and created more turbulence where the air speed slowed down and then it had to pick back up again. So anyway, sometimes stock is better. But if it was me and this bike was still around as far as production goes, I would actually be making these ports smaller and try to speed up that airflow and get some more cylinder fill, and this motor would actually rip ass. It already does, but I know there's ways to make it go faster and it still be really reliable, because this thing's just built like a shit brick house, right? Anyway, so let's go back to this whole thing. So I'm going to show you real quick. Usually what we do is we take this valve, one of these handy guys. So it's just a little rubber cup. We'll stick it on there, and then we want to just put it down in the hole. And sometimes we just give them a little kiss and spin it. And a lot of times that'll just give us a little witness line. Hard to do with my shoulder all messed up. So what I'm looking for is a mark in here, right? I'm trying to find that width on the seat face. So you can barely see it, but it's looking pretty good. We typically want to see like a 0.5 millimeter width, which isn't very much. See, 49, close enough. 51. So you're looking at 20 thousandths width. That's what we want to seat on that face of the valve. That's going to give you your best, longest lasting valve job, right? So we have a mandrel that we use. We're going to put the mandrel in. A lot of times we turn it, make sure it kind of seats flat very carefully. And now we're going to take our 45 stone. So we have all of our stones cut and we just dressed them a little bit. 45, 60, and a 30-degree angle, right? So the idea is that we want to see what this thing looks like. So I usually just kind of give it a little hand twist first. And we got to make sure our tool goes far enough in the hole. If the mandrel is too tight, then it won't seat down far enough and you won't be able to get your tool in the face like this one. So let me find something to stack this, because we just cut these, so the stone's a little shorter than it would normally be, and that's going to be a problem, I think. Yeah, because we took some love off of that. Okay, well, let's rearrange something here. All right, so I had to do a little mod, change the mandrel out, because sometimes the mandrel stands up too tall, and I want to make sure that I can get the grinding stone down into this seat face. So we changed it out, and I've got a adjustable mandrel. But here you go. So now we're just going to take a quick kiss by hand. Just give it a couple quick turns, and we'll see what we got. So now you can see what we've actually done is we've made a witness mark right here where that 45 is, right? That looks really good, actually. So if you're measuring the width of that seat, you know, you want about a 1/2 millimeter. Like I said, it's about 25 thousandths. So you can get a good idea. So we're about 60 thousandths, 65 thousandths. That's pretty good. So we don't have to do too much to move it. These heads are usually pretty tough. So what I would typically do is I'd want to bring that seat up, right? And I want to bring that 45 face closer to the top, not bring it down, and narrow it up. So I'm going to go with the 60 stone next. And then a lot of times I like to kiss it first to see where it sits. See if I actually meet that 45 or make it disappear. So you can see I'm just kind of meeting it, but you see there's some high spots and some low spots. So we're going to give this thing a little love tap with our little air tool. Not much, just a little, right? And then you want to see if it hits all the way around. It's higher on one side than the other, so you got to watch that, because if you're pushing on it, you could be bending the mandrel. So we want to make sure that that doesn't become a problem. So usually what I do is I'll rotate the mandrel. .180 out, and then hit it again. Obviously try to hit as square as you can. And it looks like we got hitting all the way around. Okay. So then we're going to go and switch out to our 30. So we're going to bring the top down a little bit. Looks like we're getting some impact. And that looks pretty good. So now we're hitting all the way around, right? So that's the 30 angle. So now what I like to do is hit our 45. Ooh, can't hold anything, I got one arm. Give our 45 a clean hit. Now we're just trying to kiss it. We don't want to take a whole bunch off because we don't want to move the seat too far up or down. The idea is that we want to make sure that we keep the valve length as close to stock as possible. So then we come back to our handy Sharpie. We're going to witness this thing again, so we're going to cover it up with a Sharpie. And if I can get one that actually draws good. Alright, let's see. I gotta get some fresh Sharpies in here. Kind of dry that. So now we can take our valve with a little lapping compound, and this is just an abrasive valve grinding compound. You can pick it up at any auto parts store. So give it a little bit of compound all the way around it. Stick your guide on there. We're gonna prop this up. And we gotta get it to stick. Pretty hard to do with my arm. Oh shit, it's not working. All right, let's try a little bit. So all we're doing is we're just running that valve compound and just putting a little bit of pressure down, lifting it every once in a while, give it about 4 or 5 turns just to see what happens. All right, and we'll pull it out. Clean your valve off first, and a lot of times you'll see exactly where that thing's hitting. So you can see right there, it's perfect. It's right in the middle of the valve face. So you want it in the middle to the top edge. You don't want it down in here, because this is where you're gonna have a problem where it's gonna start like hitting wrong and tuliping the valve a little bit. But that's a pretty good width too. So let's see how that looks when you clean it off. Use a little carb cleaner sometimes. If there's any carb cleaner in it, great. All right. So you can see really prominently and obvious where that gray area is. That's your 45. So we should have 3 angles here, right? And that's what you're looking for. A nice clean 3-angle cut, so the airflow is gonna go smoothly into the cylinder. So I'm gonna witness this one more time. Make sure you get it all the way around so you can see that it hits on all 4 sides and the circumference. Okay. Okay. Now it's hard to see in the video, I'm sure, but I can see where it's been hitting. And pretty much that's it. That's all there is to a 3-angle valve job. Not that complicated, it's not rocket science, but you just got to take your time and make sure that you get the widths right, and make sure you get the seat set at the right place on the 45 so that it sits on the face of the valve, so that you get enough pressure on it, you don't have leaks or little debris gets caught in there, doesn't cause a leak point, and then you start having a leaky valve. Anyway, that's the basics of doing a valve job. And really what makes the difference between a good valve job and an okay one is just the time you take to do it, and make sure that everything is square, everything is seated where it needs to be, and making sure that everything is just toleranced right so that it's snug and tight and it'll last a long time. That's what really makes a valve job last, is keeping those narrow margins on your valve face. So pretty much that's where we're at with this guy. We're done with that one. That's just a simple 3-angle valve grind.